Also, we have never managed to successfully port or reuse code that is heavily coupled to the real-time operating system and the hardware. And here, XP helps again as test-driven development decouples the core functionality from the hardware and the operating system. Now, reuse and porting have become common practice for us. With multi-project version control and multi-project continuous integration, we now grow products where 30% of the code is reused among products of different family lines, and 60% of the code is reused among products of the same family line. That was a solution. However, the main concern in avionics remains safety. A level of criticality is given to a software according to the impact of a failure of that software on the safety of the flight. And the level ranges from A, catastrophic, may cause a crash, to E, no effect. Document 0178B, published in 1992, specifies the objectives to achieve during development in order to guarantee the safety of flight. And the proof of airworthiness is obtained after a series of audits, which require the inspection of proofs of the activities carried out to support these objectives. As the level of criticality increases, so does the number of objectives to achieve, and they concern the software lifecycle processes. This is because safety analysis is difficult to perform for software, as it is not feasible to assess all the different kinds and numbers of software errors. So, an acceptable means to guarantee safety is to impose rigor on the process used to build the software. Therefore, a given level of airworthiness will be obtained by a given level of rigor on the development process. Now, if we take a metaphor where the water pipe is the process and the water is the product, the idea behind the guidelines is that a dirty water pipe cannot deliver clean water, and that a clean water pipe helps to deliver clean water. During a certification audit, the certifier will check that the product exclusively contains code implementing operational requirements. And the successful implementation of all the operational requirements will have to be tested. And all the code will have to be covered by a test. And all the tests will have to be run on the final airborne version. So even if you do a minor change on the software on the final version, you have to run all the tests again. And all the products, requirements, code, architecture, test, traceability, documents, will have to be checked in a review process. And these activities can imply a considerable cost. I'd like to show you now that the practice of extreme programming contributes to support these objectives. So first, XP's incremental construction driven by operational scenarios guarantees that you write code exclusively to implement operational requirements. Test-driven development systematic acceptance tests guarantee that the successful implementation of all the operational requirements is tested. Test-driven development systematic unit testing guarantees that all the code is covered by tests. The practice of test-first programming guarantees the independence of test versus code. The tests are written before the code. And all the self-checking tests are automatically run by the continuous integration system as soon as it detects a change in the mainstream code. Therefore, the latest version of the program is always fully and repeatedly tested. Earlier this month, with Alex, can you raise your hand? We quickly walked through an open space where developers were running tests on a high-integrity product. And we noticed two things. First, all the tests were run manually. Second, one of the operators was distractfully typing in an SMS message on a cell phone while running a manual test procedure. Now, I am sure that the test procedure was boring. I am sure that the operator already ran this test procedure several times. And I am sure that this very test run did not count for certification purposes. However, Alex and I thought we would feel more comfortable if the tests were automatically and repeatedly run instead of manually performed by a tired and distracted operator. So, automated self-checking tests are safer and cheaper. And finally, the practice of pair programming ensures that all the products are systematically reviewed. So, extreme programming helps to develop efficiently, and its practice brings value for certification. However, the set of by-the-book practices of XP do not provide the level of formalism with the proofs required for certification inspections. The values and the principles of XP remain perfectly compatible with safety concerns. However, some practices need to be tailored and some need to be added. For example, Alex will talk of documentation later on, and for us, the documentation must be considered as part of the product, which means that it has to be incrementally written in order to be potentially shippable at the end of each iteration. And here's an example of another very important practice we've added. During certification, we have noticed that most of the problems we encounter concern traceability and requirements. In extreme programming, you perform all the difficult activities early and often. Okay? With continuous integration, you integrate early and often. With test-driven development, you test early and often. With pair programming, you review code early and often. Requirements and traceability are an issue for us, so we've added the continuous traceability practice. As we work, we record the traceability links of our activities, and then the full traceability is automatically and continuously consolidated, quantified, checked, and finally published. Therefore, the full traceability of our activities is always shippable and up to date. And this enables us to detect the problems early and to correct them early. So, practice has proven us that Agile software development, and XP in particular, help to develop embedded and life-critical software. However, they do not provide the level of formalism required for certification purposes. So, some of the practices need to be tailored. And we've also experienced a second thing. The bottom-up approach in Agile software development matches very nicely with Lean's top-down approach to product development. Toyota develops and builds life-critical products. When you are driving your car at 130 kilometers per hour on the highway with your cruise control system on, a failure of that system may impact the safety of your ride. Toyota has designed a philosophy for developing and manufacturing products, and Westerners have called it Lean. In order to grow high-integrity products of value while reducing costs, we are trying to shift our industrial paradigm from mass production to Lean. And once again, Agile software development helps here, as I'll try to show you that most of the Agile practices contribute to the implementation of most of the principles of Lean. So, as Jim showed us, the 5 pillars of Lean are value, value stream, flow, pull, and perfection. Let's take each of these principles and see how Agile contributes. Value. Specify value from the standpoint of the end customer. So, XP recommends to have an on-site customer. Unfortunately, we cannot have an aircraft manufacturer, a pilot, and a certifier in each of our projects. So, as recommended in Scrum, our teams have a product owner. The product owner for us is an Avionics business expert who represents the aircraft manufacturer and the pilot. And the teams also have a dedicated quality assurance engineer who represents the certifier. The product owner expresses value using requirements, and he expresses his satisfaction criteria by providing acceptance tests to automate. The priorities define the succession of iterations that will incrementally grow the product. Therefore, our iteration plan maximizes the customer's return on investment.